Okay, today guys we're going to do balancing redox, and so hopefully you were in class today and maybe you're just watching this for review, but if you were absent, hopefully you feel better and you'll be back in class. But we were learning how to balance a redox reaction. Remember, a redox reaction is when you have a change in oxidation numbers, and so if you get a change in oxidation number, there's a way to balance them. It makes it look a little bit different. So I have 3 examples for you. The first one we did was in a neutral solution, meaning probably just in water. So we had Cr plus 2, so a chromium ion. It was aqueous and it was reacting with an iodine, and that made, notice it's going to change to chromium 3, and it made an iodine or iodide ion there. If we did our little labeling this went from a 0 to a -1. And when it goes from a 0 to a -1, is it being oxidized or reduced? It's being reduced because it's going down in oxidation numbers. That means it's gaining electrons. And if it's, remember, if it's being reduced, that means this is the oxidizing agent. And then we can look at this guy. He is being oxidized because it's going from a 2 to a 3. So this is being oxidized because it's going up in its oxidation number, meaning it's losing electrons. Remember, Leo says Gur. And this would be our reducing agent. So this is definitely a redox. If we didn't have a change in oxidation number, it would not be a redox. And we're going to talk about how we would go about balancing it. Most of you are looking at this right now while saying, well, I could balance that by just putting a 2 in front of the iodine. But actually that doesn't balance it, because when you balance a redox reaction, you not only have to balance the masses, meaning the same number of atoms on both sides, but you also have to balance the charges out. So one of the easiest ways to do that is to break into what we call half reactions. And so a half reaction would be take each half, the reduction half and the oxidation half, and to look at them just one at a time. So we're going to look at Cr2 going to Cr plus 3. And then we're going to look at I2 going to I minus 1. So we're breaking them into half reactions. First thing you do is you balance for mass. So we're going to look at the top equation and just balance for mass, meaning there's 1 chromium on this side, and so you only want 1 chromium on this side. So there is the same amount on each side. You want to make sure you always balance for mass first. And then what you're going to do is balance for charge. This is a plus 2 charge, this has a plus 3 charge. And so in order to make the charges the same on both sides, which is what we need it to do, you can only add electrons. You can't subtract electrons, you can only add electrons. Because these things are either gaining electrons or they're losing electrons. Now this one right here is being oxidized, so it's actually losing electrons. And we're actually going to see those electrons being lost here. So this is a 2, is a 3, and I can add electrons, and you always want to add electrons to the more positive side. And the more positive side would happen to be the plus 3. And ask yourself, how many electrons do I need to add to plus 3 to make it a plus 2? And the answer is, of course, you only need 1 electron. And so we would write an electron like that, E minus 1. Sometimes you just have a little E minus sign. I'm going to put the 1 there just where you can see it. So now this is 1 chromium, 1 chromium. This has a plus 2 on this side, and this is a plus 3 and a -1, so it makes a plus 2 on this side. So this is called balancing a half reaction. And you can look at this. Before he had the electron, and now he's given off the electron. So he's lost this electron. So this is what we call an oxidation reaction. Number 7 in your homework, you're going to just look at the half reaction. So you're just looking at the little part here, and you're balancing, and then you're telling if it's oxidized or reduced. That's all you're doing in number 7 on the homework. All right, if we look at the next one, we've got 2 iodines. This is 1 iodine. We need to make sure we balance iodines first, and you need to balance the iodine by just putting a 2 here. Now when you do that, that 2 multiplies by I, but it also multiplies by the -1. So this side over here actually has a -2 charge to it, because 2 times -1 is -2. This has a 0 charge because that's a pure element. So we got 0 on this side, a -2 on this side. So you're going to have to add electrons to the more positive side, and the more positive side in this case would be the 0. And I need it to equal -2, so I'm actually going to add 2 electrons. So this iodine is actually gaining electrons becoming reduced. Okay, so this is a half reaction. Again, in your homework, number 7, that's all they're going to have you do is a half reaction. So now we're going to do what number 9 in your homework is going to do, is going to have you combine the 2 half reactions back together. When you get ready to combine the 2 half reactions, we want our electrons to be the same because it's a give and take. If someone's giving up 2 electrons, somebody else is taking 2 electrons. So our electrons need to be the same number. This one's 2 and that one's 1. So I'm not going to half this stuff because we don't want to deal with half of I2s. So what we're going to do is take the top equation and actually multiply it by 2. So I'm going to multiply this by 2. I'm going to multiply this by 2, and I'm going to multiply this by 2. Now see, if you'll notice, I still have a balanced reaction because now this is 2 chromiums. Well, there's still 2 chromiums. This is 2 times plus 2, which is a 4. This is 2 times plus 3, which is a 6, but then it's 6 minus 2, so that's still equaling a plus 4 on this side. So when I put a 2 and everybody gets it, it's still balanced. So that's why we balance first. Then what I'm going to do is combine the 2 equations back together, and notice if I have e's on the left and e's on the right, they're going to cancel with one another, and I'm just going to bring down 2cr plus 2 plus I2 makes 2cr plus 3 plus 2I minus 1. Okay, and there's my balanced equation. Now you can check yourself, and I would suggest that you take the time and check yourself, because this will not check if you've done something wrong. You would check your mass first. There's 2 chromiums, there's 2 chromiums. There's 2 iodines, there's 2 iodines. So masses are looking good. This has a 2 times plus 2, so this side has a plus 4 charge on it because iodine is 0. This has a 2 times plus 3, so this is a plus 6. This is 2 times a -1, so you've got a -2 here, and so these together make a positive 4. So it balances. It has the same charge on both sides, and it has the same mass on both sides. So there's my answer. So that's a neutral solution, pretty easy. Again, number 7 is just going to have you do a little half reactions here, so it doesn't have you adding in it. So number 7 is going to have e's in it. Number 9 is going to have you balance a whole reaction, and notice the e's disappear. So this is going to be like your number 7 on your homework. This is going to be like number 9 on your homework. Alright, let's do a little bit harder. The next one is when we have an acid solution. When you have an acid solution, meaning you're putting the stuff and you're mixing it in some sort of acid, there's a special rule for balancing. Now we don't know what the acid is, we just know it has an acid. And the rule is if you need hydrogen, you're going to add H plus ions, H plus 1. If you need oxygen, you're going to add water. That's the rule. So anytime I need hydrogen, I'm going to add H plus. Anytime I need oxygen, I'm going to add water. Here's our one that we're going to do. We've got copper plus nitrate, and on the worksheet I left off that, the -1's there is just really hard to see. So -1, and it's going to copper plus 2 plus something called nitrogen dioxide, which is actually a gas. Okay, so my first thing to do is to break it into half reactions. So I've got copper going to copper 2 plus. I've got nitrate going to nitrogen dioxide, the gas there. Alright, so first thing I'm going to do is I'm going to balance for mass. 1 copper, 1 copper. Mass is looking pretty good. Now I'm going to balance for charge on the top. This is a 0. This is a plus 2. You always add electrons to the more positive side. So I'm going to add 2 electrons here. Okay, so the top's looking good. Is that oxidized or reduced? Well, you could look at it different ways. If your electrons are hanging out on the right-hand side, then this reaction actually has been oxidized. It actually lost electrons. Leo says grr. The other way you could look, it went from a 0 to a 2. So there's more than one way to look at that one. Alright, this one, we're going to balance for mass first. You got to make sure you remember to balance for mass. 1 nitrogen, 1 nitrogen. 3 oxygens, 2 oxygens. So in an acid solution, if I need oxygen, I'm going to add water. I need 1 oxygen, so I'm going to add 1 water. So now the oxygen are looking good, but now I've got 2 hydrogens here. If you need hydrogens, you add H+. So I'm going to need to add actually 2 H+. Okay, so now, oops, not ready for that yet. I drew it, but I'm not really ready for that. What do I need to do? I need to do some electrons here. Okay, what is the charge on this side? We've got this guy's a compound, no charges looking on him. He's a 0. This guy's overall is a 0. So this side's 0. This is a +2 and a -1. So this side over here overall is equaling a +1. So I need to add 1 little electron to this side. Okay, so now I'm ready to combine them. You can check to make sure that equals, and it does. You got a -2 and a +2 equaling 0, and this side 0. So now I need to make sure that these E's are the same. Are they? No. And so I need to multiply the bottom by 2. Here I'm going to change colors just so you can see. I'm going to make that a 2. That's going to change this to a 4. This is going to go to a 2. This is going to go to a 2, and this is going to go to a 2. And now I'm ready to combine them. Notice these E's are going to cancel out. You may see that. And then I just combined these two, so I'm just going to bring down 4H+. We won't worry about states of matter, but that would be aqueous, right? Anytime it has a charge, it would be aqueous, so if it'd be a good thing. If you wanted to write aqueous, we could write aqueous right there. In fact, I'll just write aqueous. How about that for worrying? And then it's going to be +2 nitrates. Guess what that one's going to be? See that charge? It's going to be aqueous. And then copper, does it have a charge on him? Nope. So he's going to be solid. It's good for us to practice that. And this is going to be Cu +2. Guess what? I'm going to write it since it has a charge. He is aqueous plus 2NO2. You could label this one solid. He's actually a gas, and the only way you know that is because I just told you that. And then it's going to be +2 water. And of course, water is a what? He's a liquid. And we could then check. That was a really bad line. We could check ourselves. Alright, let's check by mass first. Here's 4 hydrogens. And there's 4 hydrogens. There's 2 nitrogens. There's 2 nitrogens. There's 1 copper. There's 1 copper. Now I've got oxygens. 2 times 3 is 6, so I've got 6 oxygens here. 2 times 2 is 4, but 2 times 1 is 2, so there are 6 oxygens. And now let's look at the charge, because you can actually balance by mass and the charges not be balanced and get the wrong answer. So let's check the charge. Here you've got a +4. 2 times that is a -2. So this is actually a +2 charge hanging out on this side. And of course this one's easy because that's 0 and that one's 0, so this is a +2. So if you do these and you look at the end, if the mass balances and the charges balance, and they really have to balance, you can't just imagine it, then there's no way you can miss these. So it's kind of like in algebra where you can plug back in and check. This is the way you check, and if it doesn't check, it's better to just start over because you probably will never find your error. Okay? Alright, y'all ready to tackle the third and the harder type? And it is a basic solution. A basic solution means that it's in some sort of base, but you don't know what the base is, but it's in some sort of base solution. And the rule for this one is if you need hydrogen, well ago if we needed hydrogen, we added H+. This case, if you need hydrogen, you actually add water. And if you need oxygen, you actually add hydroxide. And the way I remember this, guys, is I just remember that the water's opposite for a base, and then I usually can figure it out. So like water for an acid is for oxygen, and so for a base is for hydrogen. So that's the way it keeps it straight in my head. And I always have to write the acid one out first. Okay, here's the formula that we're going to work with. We got chromium, which is actually a solid, and we're adding it to perchlorate ion, which is actually aqueous. And then you've got chromium hydroxide, which is actually a solid. I lost my little 3 there, that's kind of important. And making chlorate. So we've gone from perchlorate to chlorate, which, since it has a charge, we would label aqueous. Alright, so we're going to break it into half reactions. So we've got chromium, and whether or not you want to put the states on this little half, it's up to you. Go into chromium hydroxide, and then you've got perchlorate going to chlorate. I can tell it's getting late because I'm not wanting to write stuff. Okay, so here's my 2 half reactions. And so you balance for mass first. We'll look at the top one. 1 chromium, 1 chromium. Now, this needs oxygen and hydrogen. Can you see that if I would just add 3 OHs, that actually this particular formula will balance? This one's kind of unique. So if you can just balance it with adding OH, just add OH and it'll balance it. That's good. So that won't always work. Alright, so then we're going to balance for charge. This is 3 times negative 1. 3 times negative 1 is going to make this side over here have a negative 3 charge. What's the charge on this one? That one would be 0. And so we're going to add to the more positive side. Would it be the negative 3 side or the 0 side? Of course, we're going to add to the 0. How many electrons? We need 3 electrons added to this side. So that one's balanced. That's a half reaction you're looking at. Again, that's what you're. And this is actually being oxidized. I can show you and break that down later. But those electrons being on the right-hand side means it's being oxidized because they're losing those electrons. All right, here we go. This one, we've got 4 chlorines are good, 1 and 1. Always want to balance. Always balance the other element besides the oxygen and hydrogens first. It'll be easier that way. You've got 4 and you've got 3. So I need oxygens. And it says if you need oxygens, you need to add OH for a base solution. And the book will tell you if it's basic or acidic. So I'm going to add OH. Well, now I've fixed the oxygens, but I've got a hydrogen. Well, it says if I need a hydrogen, I need to add a water. Well, now I've given myself 1 more oxygen, but can you see that I have 2 hydrogens as well? I just need to simply put a 2 here. And I'll give you a hint. Not all the time, but most of the time, about 95% of the time, for every water, there are 2 OHs added. So if you had 2 of those, it'd be 4 of those. If you had 3 of those, it'd be 6 of those. So usually it's some sort of 1-to-2 ratio sort of thing going on. Okay. Can you see that that now has 2 plus 3? There's 5 oxygens here, and 4 plus 1 is 5, and there's 2 hydrogens. So this is actually balance for mass. Now we want to balance for charge. On this side, we've got a negative 1. On this side, here's a negative 1, but this is a negative 2. So over here, you're looking at a negative 3 charge. Over here, you're looking at a negative 1 charge. You can only add electrons to the more positive side, which is the negative 1, and I need them to turn to a negative 3, so you're going to actually need to add 2 electrons to that. Okay, 2 electrons to that. So now this is equaling negative 3, and that's equaling negative 3. So once you've got that done, what are you supposed to do? You are going to combine them. I'm going to switch colors so we can see. I'm going to draw a line here for you. We won't look at that top equation up there. We're just combining these 2. And I'm going to switch to green. Okay? because this has 2 electrons, this has 3. So we got a problem here because they have to be the same. So I'm going to have to find a number that both 3 and 2 will go into or multiply together. Least common multiple, I think it's called. So what's that? Of course, hopefully you see that would be 6. And so how can you make the top equation, make the electrons turn to 6? You would have to multiply the top equation by 2. That's going to make this guy go to 6. This guy's going to go to 2. This guy's going to go to 2. And this guy's going to go to 6. Okay? The bottom equation, to make those electrons turn to 6, I got to multiply by 3, making this go to 3, this go to 3, this go to 3, this go to 3, and this will go to 6. Alright, so now we're going to cancel out these electrons. If your electrons don't cancel out, then you've done something wrong, because in the end reaction, not the half reaction, but the end reaction, you can't have any electrons left over. Okay, I would also like to point out, do you see how there's 6 hydroxides here? And there's 6 over here as well on the left and the right. These guys will actually cancel out with each other as well. And you could just bring down, you got 2 Cr, and it doesn't matter the order, of course that would be solid, and then you've got 3 waters, of course those are liquid, plus 3 chlorates, which will be aqueous, perchlorates, I keep saying chlorates, and you've got 2 Cr chromium hydroxides, chromium 3 hydroxides actually, which are solid, plus 3 chlorates, which are aqueous. Again, I'm not really that concerned about the states of matter, but it's a good thing for us to practice. Alright, we could check to make sure that we did it right, and you could check charges. This is really 3 times a negative 1 is a negative 3. 3 times a negative 1 is a negative 3. So charges are looking good, but in order to make sure you got it right, you also need to check mass. Alright, two chromiums. 2 chromiums. Hydrogens. We've got 2 times 3. There's 6 hydrogens. Okay, can you see there's 3 here? Times 2 would be 6 hydrogens. Hydrogen's looking good. There are 3 chlorines. There are 3 chlorines. Now we've got oxygens roaming everywhere. So let's see what we got here. 3 here. And 3 times 4 is 12. So you've got 15 oxygens on this side. Let's check this one. 3 times 2, so there's 6 hanging out right there, and then 3 times 3 is 9, so you got 15. Okay, there's no way this thing would check if you've done something wrong. Okay, and that's it. That's the lesson. You're either dealing with a neutral one, which are the easy ones, an acid, which are like the medium ones, and then the bases, which are a little bit harder. But if you can remember that for every 2 hydroxides, it's going to make 1 water ratio on about 95% of them, then you'll be good. And if you were not here, here's your assignment. It was page 795 in your textbook, number 7 and number 9. Okay? So if you missed or are missing, here is your assignment. If you're an A-Day class, you do have a quiz over this. Your quiz over this will be on, I don't know. Your quiz on that will be on Thursday. I'm off a day, so I'm not sure when your quiz on that will be. If you're a B-Day class, your quiz on that for sure is Wednesday. And your test for if you're an A-Day class, your test is on Thursday. We might have to work this out. I don't know what we're going to do about that. And B-Day, your test is on Friday. Okay? So you guys have a terrific weekend, and hopefully this did help you.